Hey guys, and welcome to Not the Ideal Medium for Teaching Physics, Part 4, I think it is. So this chapter is going to be focused on atoms. We can start by talking about different historical models of the atom. In the early 1800s, Dalton theorized what he called the billiard ball. So the billiard ball model. He theorized that each element was its own unique solid sphere. Kinda just like a big circle. This implied that atoms were indivisible. This built on much earlier models from, I think it was ancient Greece or ancient wherever. The idea that things were made up of the smallest, of a very small thing that could no longer be separated. The idea was that they were all spheres, and different little spheres made up different things. So that was officially codified in the 1800s, and it's called the billiard ball model. Our next model came in 1904 from Thomson. This was called the plum pudding model. He actually discovered electrons. These electrons were floating in a sphere. He said that these electrons were floating in a sphere of positive charge. So electrons are in a sphere of positive charge, and they were scattered about like raisins in plum pudding. Which, to be honest, every part of that just sounds disgusting to me. This idea here was a pretty substantial advancement in atomic theory. The idea that not only were atoms not the most fundamental, but that they actually had different components. The next model actually came about 7 years later from Rutherford. In 1911, Rutherford performed the gold foil experiment. What he did was he took a thin sheet of gold film and shot a beam of alpha particles, or helium nuclei, at it, like I do on most weekends. He then measured the number of alpha particles that were deflected. So if we have a gold sheet, he would fire helium nuclei right at it. An alpha particle would only be deflected, though, if it hit the nucleus of one of the gold atoms. So this one will go right through. If we shot this one, though, it would bounce off that and it would be deflected. Probably not at that angle, but still. The ratio of alpha particles shot of alpha particles that went through to alpha particles that were deflected gave an approximate size of the nucleus of a gold atom. what he observed was that the vast majority of alpha particles passed directly through the foil without being deflected. So it was probably more like this, where the odds of actually, if you imagine that the beam of light was actually this thick, because we're pretty zoomed in, the odds of actually hitting a gold nucleus would be very small. This implies, since most of the alpha particles went through the foil undetected, that implied that the nucleus itself is very small. The nucleus of a gold atom was measured at around 10 to the minus 14 meters. I'm sorry. The radius of the gold nucleus was measured at about 10 to the minus 14. So this is the nucleus, 10 to the minus 14. The size of the atom itself is about 10 to the minus 10. That means that it's a power of like 4 smaller. It's 4 orders of magnitude smaller, the nucleus. Rutherford's model placed electrons away from the nuclear center. So he had a center that had a positive charge, and then he had electrons that were kind of just going around it, but they would actually be pretty far away from the center. So he treated these electrons like planets that were in a solar system. The atoms would have a dense core, and the electrons would kind of orbit them. Dense core. However, there were some problems with this. There were some issues with the model. One of the issues is that a circular orbit requires an acceleration. An accelerating charge, so accelerating, decelerating, a charge that's changing its velocity radiates light. As an electron radiates light, it loses energy. This causes it to fall into smaller orbits. So we would have the electron. The electron would radiate away light, or a gamma particle, which would cause it to go into kind of like a death spiral, where it's losing light, which is slowing down its acceleration, which means that it keeps falling in closer. This model did not create stable atoms. It was based on the idea of the solar system, where we have the sun and we have different planets that are orbiting at all different distances, and they can be at any distance. We assumed that since planets were stable, this would work on subatomic levels. It does not. We know that atoms are stable. Otherwise, we would not have the world. This means that we can't treat this system what we call classically. When we treat a system classically, that's like the classical mechanics, like the first semester of things that we did. If we treat a system classically, then that essentially means that things can be as, there's no fixed distances that things can move. Essentially what this is saying is that we need to find new physics. and that is inconvenient.